we're going to go ahead and work through the review packet together in this video. You guys have the answer key, but in case you have any questions, I'm just going to go through it so you can see an explanation of the questions you were concerned on. So the first section here wants us to classify the triangle by its angles and sides, as I have two separate lines. So remember, your options for by angles would be right, acute, obtuse, or equiangular. And then by sides, your options are isosceles, scalene, or equilateral. So this triangle very clearly has the 90-degree angle right there. I don't need to know about the other two. I can see that they're acute, but once you see that you have that 90-degree angle, you can say that the triangle is a right triangle. And then I see that I only have two congruent sides, so that would make it isosceles. In this triangle, I notice that there is a 95-degree angle, which is obtuse. I don't need to know these other two angles because once you see that you have one obtuse angle, that fulfills the definition of an obtuse triangle. So again, once you notice that it's greater than 90, then it's obtuse. That makes the whole triangle obtuse. And then again, I only see two congruent sides, so that makes this an isosceles triangle. Over here, I have 40, 60, and 80. Those are all acute. So when I have all three angles are acute, meaning they're less than 90, that classifies the full triangle as acute. Now, I don't have any markings on the sides like I did for these two, but what you want to notice is that all the angles are different. So if all the angles are different measures, that will mean that the sides are going to be different lengths, because as the angles are opening or closing, that's going to make the sides across from them shorter or longer. So this side is going to be different than this side, is going to be different than that side. So when all the sides are different lengths, that is called scalene. All right. So they may not give you the markings, you just need to be able to figure out that if all the angles are different, that means all the sides are different. So be careful with that concept. All right, now we have this question right here. We are looking for y, which is the angle right here. This is an exterior angle. So remember on day one, we talked about the exterior angle theorem, which states that if you have an exterior angle, it is equal to the two interior angles that are across the triangle. You never want to use the one that's touching. All right. If you know this one right here is some number, you could use linear pair to solve. But if this angle is not provided, or it's a different variable like x and then this is y, so you can't group them together, then you would go across the shape and you would add these together. So this is a really simple question. All you have to do is take 38 and add it to 90, and you will get the correct answer for y. And so you should get 128 for that question. Excuse me. This next question for number 5 is using parallel lines. So we're going to be using the parallel lines like we used in Unit 3 to fill out the missing angles, which are right here and right here. Then once we have more information in the diagram, it will become pretty clear how to solve this question. So I'm going to be using this parallel line and this parallel line, and then we have two options for the transversal. We have the one over here and the one over here. I'm going to do this one first. Okay. So notice you'll have a picture that looks like this. If you were to draw it over on the side, I have a 72 right here, and the angle that I'm interested in is right here, all right? Or right here if you want to do that too. But I specifically want to find this angle because I noticed that I have a small triangle right here. Okay, so it might be useful to know this angle, which is the third angle in the triangle. So when I redraw the diagram or I just look at it, I notice that these are corresponding, so that means that they're equal. So I can put a 72 right there. You can do the same thing for this transversal. If you switch transversals, you can have a picture that looks like this. I have a 55 right here, and this other angle that might be helpful in the big triangle. If you choose to look at it and you see a big triangle instead of a small triangle, then I would be interested in this angle, which is right here. And again, these are corresponding, so that means this is also 55. Now again, it's really just whatever you see first. You may notice a small triangle first and only do this, which is fine, or you may see the big triangle and want to do that. Either way is fine, or you could add both angles, really doesn't matter. But once you have either one of those filled in, you should notice that you have a triangle, and you should remember that all the angles in a triangle add up to 180. So regardless of whether you use the small triangle or the big triangle, you notice the angles are the same. So your equation is going to be y plus 55 plus 72 equals 180 because all of the angles add up to 180 in a triangle, whether it's the small one or the big one. And oops. So we're just going to do a little bit of math, and once you work through all of that, you should get that y is equal to 53. Okay. All right, this next one here, number 6, we're looking at a isosceles triangle. That's the first thing that I noticed. I have 2 congruent sides here, so that means that my triangle is isosceles. So before I even look at what they're asking, I'm just going to automatically add these markings in here, because you should remember the base angles theorem says that if you have 2 congruent sides, you have 2 congruent angles. And the 2 angles that are congruent are the ones that are at the edges of the 2 sides that are congruent. The point where they meet, remember, this is called a vertex angle. That's not equal to the other 2. So the 2 angles are the ones at the base of the 2 sides that are congruent, not where they meet, at the bases of those. Okay, so I can add those in, and so I want to keep remembering as the problem's go ongoing that this is equal to this. All right, so the first part of the question is asking for the length of SL, which is right here. I notice that they are equal, so if this side is 5, that means this side is also 5. Then they want me to find the measure of OSL, which is right here. And they also want to find the measure of SOL, which is right here. So they want us to find these 2 angles right here. Just for the sake of having a variable, I'm going to put an x here. And because they're equal, I'm also going to put an x here. So when I solve for x in this picture, it's going to give me the answer for both of these at the same time, because they're equal. All right. Now, because I know they're equal and they all have a little label here, I see 1, 2, 3 angles in my triangle are labeled. When you notice that all 3 angles have a label, you can use the triangle sum theorem, which says that all of the angles added together equal 180. So if you want to, you can combine them automatically. That's fine too. But when you subtract the 135 and divide by 2, you should get that x is equal to 22.5. And because the angles are equal, they should both be that measure. Okay, you can check to make sure you're right by taking 22.5 plus 135 plus 22.5. Make sure that you get back to 180. The next angle they want us to find is the measure of WSL, which is right here, this angle, right here. Again, that is an exterior angle, so I'm going to be using, well, there are 2 different methods you guys can use. Once you have this angle right here, these 2 are a linear pair. Right? This angle that you found and this angle that you're looking for, those are a linear pair. So you could just say that they add up to 180 and solve that way. Or you could notice this is exterior, so you could go to these 2 angles over here. You know this and you just found this. You could add those together and get this answer. There are really 2 options. In this one, we didn't have 2 options because this angle was not provided. But in this one, if you have the angle that's adjacent, they are a linear pair, so you can go that route. So whichever route you choose to go, you should get that that angle is 157.5 degrees. Okay, so either add these 2, this is a 22.5 that we just found. You can say 22.5 plus angle WSL is equal to 180, or you could just add these 2 together and get your answer right away. It's up to you. This is a very simple question right here. You just have 3 angles of a triangle all labeled. This is the only variable I'm looking for. All you have to do is add them together and set equal to 180, because that's the triangle sum theorem. All the angles in a triangle add up to 180. You write the equation, you solve, you should get 20. Very simple question. All right, number 8 is another question involving an exterior angle right here, and the variable we're looking for is inside. So it looks very similar to this question. They just switched where they want the variable to be. So we're going to be using the exact same rule. We're just going to write the variable in a different spot in the equation. So this is still the exterior angle, so the rule still applies. This is equal to these 2 added together. So I'm going to write an equation. Just like I wrote the equation up here, I'm going to do the same thing down here. The exterior angle is equal to the interior angles added together. And remember, you don't use this one at all. The one that's touching, it's not even provided, so you can't use it. But when you have an exterior angle, you go across the shape all the way over here and use these 2. So 160 is equal to z plus 90. All you have to do is subtract the 90 and you'll get your answer. It should be 70. Okay. Now this one over here, again, is exterior angle theorem, because I have the exterior angle, which is right here. And just a reminder, an exterior angle is when you take one side of a triangle and you continue drawing it, and it's an extension, and then you can draw a little loop until it comes up and hits the side of the triangle. So this is another exterior angle. And remember, the theorem says that the exterior angle is equal to the two inside angles added together. So I would be using these two if I use the exterior angle theorem. I don't have this one, so I have to use the fact that this is an isosceles triangle to find it. So this is like two questions in one, really. So I realize I don't have enough information, so I'm just going to look at the isosceles triangle. Whoa, I tried to redraw it and that did not work well. So if I redraw the triangle, kind of like this, I know it's not to scale, it didn't come out very well on the computer, but I have that these two are equal and this is 70. So if I'm just looking at the isosceles triangle, remember when you have two congruent sides, you have two congruent angles, and it's going to be these two. Remember the point where the two sides meet, that's the vertex angle. That's not one of the congruent ones. You want to go down here to the bases of these sides. So these two are equal. So I'm going to do a separate question to find out the measures of these. Now just for the sake of solving, I'm going to call them x, which is the variable that I'm not using. So that's a safe variable to use. Don't try to use the same variable in the original question. If you're doing like a tangent off to the side, make sure you use a different variable. So I'm just going to solve for x the same way that we did in this one. So x plus 70, or 2x plus 70, equals 180. Oops, oh gosh. All right, hold on, let me do my math real quick on that because I don't have it written down here. So, oh, excuse me. Each one of these angles here is 55. Oops. So I'm going to put that into the diagram, 55 and 55 right there. So once I know that those two angles are 55, again, I have two options. Just like in this question right here, I can either do linear pair right here to solve for y, or I can say that the exterior angle is equal to this plus this. It's really up to you. Once you have this angle labeled as a number, not a variable, you can use linear pair to do that. But regardless of which scenario you use, you should get 17. So it's just like the question up here. You choose whether you want to do linear pair or you want to add these two together. Okay, you have all the information that you need. If you were to do the exterior angle, this is what the equation would look like if you were curious. Exterior angle equals these two added together. And then you would solve and get 17. Okay, this question is asking us to solve for the value of x, and we're going to have to use we're going to have to use the triangle to figure out how to do this. So they haven't given us any markings about congruency. Like in the other triangles that we saw over here, we had parallel lines, or we knew that it was isosceles, and we had congruency markings that we could use to help us. Over here, we don't really have those congruency marks like in the previous questions. So we're going to have to analyze to see what kind of triangle this is, and then we can figure out how to solve from there. So right now, I notice that it is a right triangle. The fact that it's a right triangle does not tell me anything about the sides. So it's cool that it's a right triangle, but that's not going to help us currently. In order to figure out what kind of triangle it is, I need to know, are these two sides equal? In order for these two sides to be equal, or for it to be isosceles, in order for the sides to be equal, the angles have to be equal. So I'm going to do a quick side question. I have this is 90, I have this is 45. I'm going to figure out what this angle is to verify whether it's isosceles or not. So if I have 90 and I have 45, I have to figure out what's the third angle that would get them to 180. If you do the math real quick, you do get that this angle is also 45. So you'll notice that the two angles are equal. If the two angles are equal, that means that the two sides are equal. So be careful that you guys aren't just assuming that sides are equal in triangles. You have to use the angles to verify what kind of triangle it is. If the two angles are congruent, then the two sides are congruent. So again, do not assume you need to use equality of angles to get the sides or equality of sides to get the angles. So please make sure you're being thorough and showing the reasoning of why you can say that these two sides are equal. Once you do that, you can just say that the two sides are equal by writing an equation and then solve. And when you solve, you should get x is equal to 4. I'm going to leave you guys to do the algebra on that one. But again, for this one, you just have to find the angles. When the angles are equal, that means the sides are equal, and then you go. All right. All right. In this one right here, we had one like this in the notes. So there are two different triangles, and I'm going to treat them as separate triangles to solve. So I'm just going to worry about this triangle right here first, because I notice it's the triangle that has two angle measures, while this one just has one. So this has more useful information. So in this triangle, I have 18 plus z plus 65 equals 180 because of the exterior angle theorem. When you solve for z, you should get 97. Okay, once you have 97, you can do two different things to get y. You can do the linear pair immediately to get y, or you could use the 97 to find x first using the exterior angle theorem, and then once you have x, you can do the triangle sum theorem again. But I feel like it's probably easier and quicker for you to see that these are linear pairs, so I'm going to do that method. So these two angles, because they are adjacent and create a line, please do not say that the 97 and the 51 are supplementary. That doesn't make any sense. I understand that they're on the same line, but that doesn't make them a linear pair. For them to be a linear pair and be supplementary, they have to actually be touching. They have to be together to create the line, which is not the case with random angles that are just on the same line. So please don't make that mistake. So these two are a linear pair, which means they add up to 180. So that makes y equal to 83 when you subtract. And then because this is now 83, to find x, you can do the triangle sum theorem just like we did for z. You can say x plus 83 plus 51 is equal to 180 using the triangle sum theorem. And then when you solve, you should get 46. All right, so we saw one like that in the notes. You just work your way around the triangle using them separately. All right, this one, I have two different variables that I'm solving for, the a and the b. I see more of the b than the a, so I'm going to start with that variable. I notice that b is in both of these angles, and then I also notice that this is an isosceles triangle because of these two markings. Now, in order to find a relationship between these two angles, I'm going to use the sides. Because the sides are equal, that means that these angles are equal. Remember, where they meet is not an angle I'm talking about. The base angles that are congruent are at the bases of these two sides. So these two are equal. And again, please make sure you're not just assuming that they're equal. If these two markings were not here, you would not be able to say that they are equal. That you actually wouldn't be able to solve the question unless they had these markings. But regardless, make sure that you only say that they're equal if the sides are equal and vice versa. Okay? So these two are equal. So when I solve, I should get that b is equal to 6. All right? And then once you solve for b, I can use that to solve for a by plugging it in. So if I plug in 6, let's see, that would be 17 and 17. All right, so if I plug 6 in here and 6 in here, I get 17, 17, and then the only variable I don't know is a. So I'm not going to use the isosceles triangle theorem to find a, because again, that's not a base angle. I'm going to transfer to the triangle sum theorem, because now I know this is 17 and this is 17. I can just add these together, 17 plus a, and get 180. So remember, whenever you're working with a triangle, if you have two numbers and then one variable, all three of them are labeled and two of them are numbers and just one of them's missing, this is your failsafe. This is the method you would use. So when I go ahead and do that, I should get 146 for A when I do the algebra. All right, this one right here is interesting. It gives you the markings in the directions, and so you're going to have to add those to the picture. So I know that A is 35. I know that C is 4x minus 3, and then they want us to find the measure of angle B. So notice that they involve x in this question, so I'm going to have to find x first and then plug it in to find the answer. Now, I don't have all three angles labeled, so I'm going to have to analyze the triangle to see what's going on here. I can't just say that these two are equal. I don't have a basis for that. Okay, so just look at the question, don't rush. So I notice that these two sides are equal. All right, remember, when two sides are equal in a triangle, that means that two angles are equal, but you have to figure out which two. Remember, it's the base angles. So the two angles that are at the bases of these two sides, those are equal. It's not the one where they meet. This is called a vertex angle. The base angles are here and here at the ends of these two lines, not where they meet. All right, so that means that if these two are equal, and this was 4x minus 3, I could write another 4x minus 3 here. Remember, they don't say that in the directions, but now that I know they're equal, I can write that in. And now that I have 1, 2, 3 of these angles marked. And because these have the same variable, I can add them all together and add to 180. Over here, I said to look out if you have two numbers and one variable, but you can also add them together if you have one number, but the variables that you have are the same. If they were different variables, you don't want to try to add them to 180. It's not going to work out. But if they're the same variable in two different angles, feel free to add them together because we can just combine like terms. So the equation would be 35 plus 4x minus 3 plus another 4x minus 3 is equal to 180. Okay, and then of course you guys should know how to do the algebra. So when you do that, I know it's an awkward number, but you should get 18.9. Okay, and so that's what our x value is, but it didn't ask us to solve for x. It wants the measure of b, so I had to find x first, but now I'm going to plug that in to the expression that I found for angle b based off of these other two. I know that these are equal. So this is angle B. So I'm going to take this value, plug it in right here. So 4 times 18.9 minus 3. And that should give you 72.6. All right, so notice they didn't give you everything you needed in the directions. You had to be careful on what kind of triangle it was. Two sides are equal, two angles are equal. You write that here, and then off you go. All right, so please make sure you're looking out for those details in the picture or the directions. All right, this one is asking what measure of angle A will make these two triangles congruent if the measure is represented by these expressions. All right, now remember, when they say that the triangles are congruent, that means everything about the triangles are congruent. All right, so these sides are equal, these sides are equal, these sides are equal, and all the angles are equal. So if we know that the triangles are congruent, that means that the angles are congruent. So they give us the measure of angle A and the measure of angle X as expressions. So because I know this, because I know the triangles are congruent, I can say that all the little bitty pieces are congruent. Remember, that's our CPCTC from proofs. If the full triangles are congruent, every little piece is congruent. So I can say angle A and angle X are equal. So I'm going to set those expressions equal to each other, like this. Excuse me. And then I'm going to solve. So using algebra, we notice we have a fraction here. You guys have to get used to solving with fractions. So I'm just going to multiply everything by 4 to get rid of the fraction. Just makes it easier, right? Excuse me. And then you guys will be solving for x. So you'll subtract over, you get this, and then that, and then x equals 8. Now, you do get x equals 8, but notice the question wasn't asking for x, so please make sure you're reading very carefully. They wanted to know the measure of a. So once you find x is 8, you're going to plug that in, and the measure of angle A that you would want as a value, not an expression, okay? When they ask for the measure, they actually want the number, so once you plug in 8, you should get that measure of angle A is 13 degrees. Okay, so that's where they want you to stop. All right, okay, same kind of question here. They want to know what value of x will make the triangles congruent, right? So they're asking, we want the triangles to be congruent, so you can pretend that they are for now, and then just figure out the x that comes from that situation. And so again, I've warned you, and this may not be in the test, but you have to make sure that you read the directions. Over here, I noticed that A and X were corresponding, and so that's why they were equal. So you want to make sure you read the name to know what's corresponding to what, because I have 2 different sides here and 2 different sides here that I need to match up correctly. So when I look at this side right here, AB, and you look at the name AB, that corresponds to XY, which is right here, and that should make sense because I have 10 and 10. That matches. Cool. What if I looked at BC, which is these two? BC corresponds to YZ, which is right here. Okay, so that doesn't look right. They've been twisted. This triangle has been twisted or reflected so that now this side is on the left. So they flipped it like this. But when you just look at the picture, I know your instincts are going to say that these two are corresponding. But you can't just visually look at the triangles and see that, especially when they're equilateral like that. Well, we don't know that they're equilateral, but when the sides look very similar like this and you can't really tell what's going on, what side corresponds to what, you have to depend on the name. So whenever they give you the names of the triangles, please do not ignore that. You need to read that name to figure out what's corresponding. So these two are corresponding, and because the triangles are supposed to be congruent, that means that the sides are congruent. So I can just take those two and set them equal to each other. Okay? So when I solve, you should get that x is equal to 3. And they were just asking you for x and stop there because they weren't asking you to plug in anymore. So find x and stop. But again, the trick for this one is recognizing what corresponds to what, even if the triangles have been reflected, which you will not know unless you read the name. So be careful. All right. These questions are what we practiced primarily on lesson 2 and 3, I believe. You need to add any information that is relevant and allowed to be added using our 4 reasons: vertical angles, reflexive, parallel lines, or isosceles, and occasionally the definition of perpendicular if you need to fill in another right angle. So we're going to add the information, which is required before you get your answer, and then we're going to decide which of the 5 rules works. Okay, so in this picture over here, I notice that I have 2 right angles, I have 2 sides that are congruent, and I have 2 sides here that are congruent. Oh, wait, where are my color pencils? I have a color coding strategy that may or may not be helpful if you're still having trouble deciding whether sides or angles are between or not, like if you're having trouble seeing the sandwiches. I have a color coding strategy you can use, but I'll introduce that when it's relevant. In this situation, I notice that I have side, angle, side, side, angle, side. Right, I have 2 sides. Well, here I can show now. So the color coding strategy is to pick one color for the sides and to shade them in like this, and then pick one color for the angles and draw a little dot or color in the angle like this. And hopefully that should illustrate the fact that this is inside. Remember, because the definition in the rules that use the word included, so you should see that it's included or inside of the crease in the sides where they meet. So that's what it should look like when you have the A in the middle. You should have the angle in the crease of the 2 sides. So this is a side angle side rule. They're corresponding and they're equal. So that's how you can use a color coding to see if the angle is inside. If the green had been here, that's clearly not inside of the crease where the 2 sides meet, so that would not be between. So that's how you can use the colors to help you if you would like. In this one, I'm going to be using the perpendicular rule, right? Right, because they're perpendicular. If I have 1 right angle, I also have 1 right here. So use a perpendicular to fill that out. And then I'm also going to use reflexive to add this side right here. So what I notice now is I have angle, angle, side, angle, angle, and then I already colored that in beside. So these 2 triangles are congruent by angle, angle, side. And I didn't call it angle, side, angle because this red side is not in between the 2 green angles. So that's why it's not going to be angle, side, angle. That's not the one I want to use. It's angle, angle, side because the side's not in between. Okay, so that's that one. This one over here, I notice that I have a reflexive that I can add right here. You could also, because this is isosceles, right? The full triangle is isosceles because these 2 angles are the same. That means that these 2 sides are the same. Okay, so you can do that if you want to. Actually, wait, you need to because there wasn't enough information before. But when you add this side right here using reflexive, and then you add these 2 sides using the isosceles, then you should notice that you have side, 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 or side, angle, side. Okay, so you can use either one of those methods, whichever one you guys see first. But if, again, you're trying to use the color coding and you're trying to illustrate why it would be side, angle, side, when you highlight the sides that you have, and color in the angle, you should notice that these angles are tucked nice into the corner of 2 sides meeting. So that is what's needed for side, angle, side for the sandwich to happen. But again, you can choose either one of those is fine because you have 3 sides or 2 sides with an angle between. Either one is appropriate. This one over here, again, I can complete the perpendicular because I have 2 right angles at the intersection. I have a reflexive that I can add. Okay. Now I notice that these are right angles. Now when I use the color coding, I have sides, and then another side, and then I have angle and an angle. Now, using the color coding, you should see that the angle is not tucked into the corner of the 2 sides, which is necessary for side, angle, side. So this is not side, angle, side. This would be side, side, angle, right? side angle, because the angle is not in between the two sides. Now we've talked about before that this rule does not work. However, notice what kind of triangles these are. This is a right angle and this is also a right angle. So remember, when you have side angle, but it's a right triangle, we have another rule that bypasses this little dilemma, okay? Because it's a right triangle, instead of thinking about it as side angle, we're going to think about it as hypotenuse leg. So this one is actually congruent by HL. Okay. There's another way that you can see this. Because the two sides are equal here, this would qualify as isosceles, just like this one does. So because the two sides are equal, you also have two angles that are equal here and here. So if you wanted to, you didn't see the HL right away, but you saw the isosceles, you could also say that these triangles are congruent by angle, side. So either notice that it's a right triangle, which gives you HL, or you could see the isosceles, add these two angles here and say angle, side, angle, side. Or, well, it doesn't matter which side you use, but angle, side, or you could use the reflexive side. But either one of those methods is correct. For any other triangle, side angle won't work, but if it is a right triangle specifically, you would switch it to HL. All right, for this one, I very clearly see that I have angle, side, angle. Hopefully that's pretty clear to you guys. I don't have to add anything, it's just all provided. For this one, I have vertical angles that I can add, okay? And so I'm going to use my color coding again if that's helpful. I have this side, and then I have this side and this side, and then I have my angle here and my angle here. So you'll notice that within one triangle, because you want to make sure you're just looking one at a time, when I look at the triangle, I have my two sides and the angle's over here. The angle's not in between. It should be tucked in the corner where these two sides meet, and that's not happening. So in this situation, this is a side angle, and because it's not a right triangle, that rule doesn't work. So this would be not enough information. So again, use the color coding to see that these angles are not inside the corner where the two sides are meeting, so it's not side, because the angle has been misplaced. All right, over here, again, I have reflexive. All right, and then I notice I also have parallel lines. So if I use the Z trick like this, I can say that the two corners, right here and right here, those are congruent. Right, these are parallel lines, but they were specifically the alternate interior angles. Okay, so now when I look at the picture, I see one side. There's only one side that's equal. Right? Parallel does not mean congruent, so please do not add that. I have one side that's congruent, and then I have two angles here and two angles here. So in each triangle, I have angle, side, angle, side. So that's why those two would be congruent, right? It's not angle, side, angle, because again, this red side is not in between the two green. The two green angles are here. The side is not in between, it's outside. So again, you can use the color coding to see that pattern as well. This one looks an awful lot like these two are perpendicular, but you cannot assume that they are right angled, or you can't assume that. We can only go through those 4 ways that we can add information. Reflexive, no. Parallel, nope. Isosceles, no. But I do have vertical angles here and here. Okay, I don't know what their measures are. All I know is that they're congruent. So now, again, I'm going to color code this side and this side. So each triangle has a side, and then this angle, and this angle, and this angle. So you'll notice in each triangle, if you want to cover them up so you only see one at a time, I have 2 angles and the side in between them, right? And then 2 angles with the side in between. So this is angle, side, angle. Right? So again, color coding, hope maybe helpful. If it's not, don't worry about it. Don't worry about trying to use the color coding method if it already makes sense. But hopefully that's helping those of you who were a little bit confused before. And then this one, you should be able to see pretty quickly that we have reflexive here. Oops, I forgot to. We have reflexive, which gives us side, 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 side. So that one's pretty straightforward. Right? Next one up, I have D is the midpoint of BC. So remember, midpoint means that it's cutting in half. So I can say that these two are equal because it's the midpoint of this segment. So there's nothing else that I can add because there's no vertical, there's no reflexive, there's no isosceles, and there's no parallel. So I have to base my answer off of this. I notice that I have side, side, angle. All right, the angle's not in between the two sides. I'll just color code one of the triangles so you can see that. This angle right here is not tucked into the corner, so it is not in between. So this is side, side, angle. And remember, that rule doesn't work unless it is a right triangle. Right? So I notice that both of these angles right here are right angles. So that means that instead of saying not enough information, I switch automatically to HL because they both have the hypotenuse and corresponding legs being congruent. Okay? Again, any other triangle, this wouldn't work, just like we saw in this one. When it's a right triangle, you use HL. Now, I'm also asking for this one that you complete the congruency statement, so you guys need to be able to do that too. If I name the triangle in a particular way, you need to match up the corresponding vertices in naming the other triangle. So if I start with A, I'm going to start with E, because those are corresponding. And then B corresponds to C, and D corresponds to itself in the other triangle. So that's the appropriate name for that one. Over here, I have that AD is parallel to CB, and that AB... AB, there it is. AB is congruent to CD. So I have this information provided with the given. I can also add this right here with the reflexive property. Okay. Because I have parallel lines, I'm going to actually use them. I had to put the marking in, but now I can use them. So parallel lines gives me this shape right here. So I know that these two angles are congruent, right? Using the parallel lines, but specifically the alternate interior angles. Right? So what I have in each triangle, again, I'm going to use color coding. I have two sides and one angle in this triangle. And then I have two sides and one angle in this triangle. Let's see how they're arranged though. So I have side and then angle. The angle is not in between the two sides, so this would technically be a side-side angle. Now, these are not right angles, so I can't bypass this problem using HL because they're not right triangles. So whenever you see that the rule you have is side-side angle, that doesn't work. So this would be not enough information. Okay. These ones have a lot of information provided. So I have AB is perpendicular to CD, so that means I can use the definition of perpendicular to put a 90-degree angle. AB is congruent to CD. So I'm going to do that just to illustrate that I'm talking about the whole thing. So AB is congruent to CD. EC is perpendicular to CD, so I have another right angle right here. And then A is congruent to D. If you want to, you could draw the triangles separate from each other. If you think that might be helpful, if them touching is too confusing, you can separate them a little. And then you can do this. Might be helpful so you're not confused on like whether you're talking about this short part or the whole length. You can separate them and see it a little bit clearer. So now you should notice in each triangle I have angle, side, angle, which you can see in either form of the picture. So these are congruent by angle, side, angle. Now I know they have right angles, but remember that doesn't automatically mean that HL works. For it to be HL, you need to have the hypotenuse and the leg, as well as the fact that it's a right triangle. So don't just assume that because it's a right triangle, HL will work. Make sure you're looking for the appropriate information. And then because they're congruent, I'm going to fill out the congruency statement. So A, B, C. So A corresponds to D. And you can see that in the way that the information has been provided here. I had to put a congruency mark here that matches this congruency mark. So A corresponds to D. B, which is the right angle, should correspond to the right angle in the other triangle, which is down here. So B corresponds to C. And then C, if we kind of travel around the triangle, ABC corresponds to DCE, the other vertex in this triangle. So you guys can use the way that when you separate them, you can see it a little bit better if you want to label like this. Or you could also use these to help you figure out what corresponds to what. All right, so then these ones here, these are where you guys have to draw a picture for yourself. They're going to give you the names of the triangles, so you don't have to do any guessing work about what corresponds to what, because they've already given you the information here. So you can just draw triangles. I know there's not a whole lot of space, but you can just draw two little triangles and call them A, B, C, and D, E, F. So because I gave you the names, you already know what's corresponding to what. So you can just name them in whatever order you want going around the triangles as long as they match. We are trying to find the third congruency statement that gets the triangles to be congruent if I have these two. And make sure you're reading the directions to know what rule we're supposed to be using. So in this picture, I know B is equal to E, BC is equal to EF, and I want them to be congruent by angle, side, angle. So I currently have one angle and one side. One angle, one side per triangle. That means I need to find another angle, and I need the angle to make a sandwich. So I have two options, either A or C, or D and F. To create that sandwich, I'm going to need to use angle C and angle F to get that angle, side, angle. So I'm going to say angle C is congruent to angle F, like that. I'm going to redraw my triangle so I can reset A, B, C, D, E, F. All right, this time I'm using the angle, angle, side method. So A is congruent to D, AB is congruent to DE. Now notice that these are different. This was angle, side, angle, and this is angle, angle, side. This means that the side should not be between the two angles. So I have the angle and the side. I need the other angle, but I need to make sure that the side is not in between. So I would not choose B. If I used A and B in this triangle, that would be angle, side, angle, but I don't want the side to be between. So I'm going to choose angle C and angle F again. But they create different situations because we had a different side in each one of these. Okay? So be careful with how you are. Oh, I just realized I named the triangles in a different way for both of them. But again, that should illustrate that it really doesn't matter how you name the triangles as long as it matches. But you would want to choose angle C and F to keep it from not being a sandwich. The side should not be between the two angles. All right. This question is a multiple choice question. So it says, given the diagram, which is a true congruent statement. So this is a question asking you to check to make sure all of the vertices are in the correct order. They've said that the triangles are congruent, but they may have the letters in the wrong order. So that's what we're checking for this one. So I'm just going to go step by step, see if it works or not. So if I start with A, B, C, they go from double to single to unmarked. All right, that's how they set the stage here. Let's see if it goes the same way. So A is supposed to correspond to E, because these both have the double mark. So I notice right away that A and D do not correspond, so I know that one's not it. This one's also not correct because it, again, has A and D corresponding. All right, this one looks promising. We have A corresponds to E, which is correct. B, which is a single mark, should correspond to D, which is also correct. And C corresponds to itself. So this is going to be the answer we choose. So that's how you would go through this question. Just make sure all the letters are matching. Okay. Now my computer printed the picture cut off, so I had to draw it in again. But this is an example of the kind of proof you guys are going to see on the test. There are actually two proofs. You guys will have a little box here on the test that has all of your options. You need to be careful because there are some trick options on there that has some issues with them. So you have to make sure that you're paying attention and not just writing stuff that looks kind of correct. You have to make sure that it is correct how it's written. So I'm going to go through and write down what's needed to fill out the proof. So they say that the given comes first, which is always true. So I'm going to take the two given statements and write them down. So I know AB is parallel to CD and BC is parallel to DA. So once you get that out of the way, just to set the stage, why did I do that? We're going to go back and put information into the picture before we continue with the proof. So I know that AB is parallel to CD, so I'm going to mark that. And I know BC is parallel to DA. So I'm going to put single marks here and double marks there just to show that there are different sets of parallel lines. That's all that's given. So now I'm going to look at the picture and see what I can add based on what we've learned in the previous lessons. So because I have parallel lines, I'm going to use the Z trick. I'm going to use color coding here just to illustrate. So I have one Z right here. So that means these two are equal. Because I have another set of parallel lines, I'm going to do another Z. They both use the same transversal, which is totally fine. And then I would get that these two angles are congruent. And then I can also use reflexive to say that this segment is congruent to itself, one per triangle. Okay? So that would make these triangles congruent by side, angle, side, side, angle, side. Sorry, angle, side. Oh my gosh. Sorry, angle, side, angle, angle, side, angle in both triangles. There we go. Now notice this is a small picture proof. So once you showed that the triangles are congruent, you would finish by giving this step, which is defended by CPCTC. Hopefully you guys remember that. So I'm going to go back into the proof and explain all the markings that I put into the picture. So I said that angle 1 and 4 were congruent and angle 2 and 3 were congruent. That was based on the parallel lines. But you don't want to just say definition of parallel or because of parallel lines, all right? Because that's not really explaining why the angles are congruent. It's true that the lines are parallel, but that doesn't give me enough information to show why the angles are congruent. So I have to specifically mention the theorem that states that alternate interior angles are congruent when lines are parallel. And that's called the alternate interior angles theorem. And feel free to abbreviate. I don't know if it's abbreviated on the test or not, but you can abbreviate if you want to, as long as I understand. So again, because they're alternate interior angles and the lines are parallel, that makes them congruent. So this is the reasoning you would give. Now we also use the reflexive property, right? We remembered the reflexive property gives us this marking, but now you have to write down what that marking means. So remember, this mark means congruent. So I'm saying that this is congruent to itself. But remember, when you have the zigzag, you have to change the order of the letters. So I would say DB is congruent to BD. So whenever you have the zigzag like that, or the triangles have been reflected, you can see the top triangle has been twisted, reflected. So whenever that happens, you have to switch the order of the letters for reflexive. And then once I had all that, I knew that the triangles were congruent by angle, side, angle. And to finish a small picture proof, you finish with CPCTC. Okay? This question right here is asking us to determine if the triangles that are described with these points are congruent. So remember, with the coordinate plane, you guys have to draw the points first of all, and then connect the dots to create triangles. And then you have two options. You can use distance formula if they're all slanted and you have to find the lengths of their sides. You could also try the slope method if that works for you, or if they are right triangles, you can use the side angle side. So let's see what we have. We have -1, which is t. We have -2, 2, which is S, and we have -1, 2, 3, 4, 5, -1, which is right here. And that's R. So that's one triangle. And then I have 2, -1, which is H. 1, 2, 3, -2, which is N. And then 1, 2, -5. 1, 2, 3, 4. Wait. 2, 1, 2, 3, 4, 5. Yep, right there. Okay, and then what was that? D, right here. Okay, we're trying to see if these triangles are congruent. So using the name, they've told us what corresponds to what. So the TS and the HN correspond as the two smallest sides. The TR and the HD correspond as the longest sides, and then we have the medium sides here. So again, there are two ways you can approach this. We can't use the side angle side because these are not right triangles, right? So we can't use that shortcut that we would have seen before. We can't use side angle side. But you guys have two ways that you can approach these questions. You can either do the slope method or the distance formula. I guess I'll briefly go over both so you can see them. So for the distance formula method, I can see that I have two flat sides here, so those ones are nice and easy. I can count. So 1, 2, 3, 4 is the length here, and 1, 2, 3, 4 is the length there. Now I just need to find the lengths of the short sides and the medium sides. So if I wanted to do T and S, that would be these 2 points for the distance formula. So you guys should get used to doing this, right? We've been doing it for a while. So if I do the x value minus the other x value, that'd be -1 plus 2, which is squared. And then the y value minus the y value, which again turns to a plus because it's a double negative. If I keep going, then that would be -1 plus 2 is 1, 1 squared is 1. And then I get the same thing. So this is square root of 2. So this right here, the TS is square root of 2. If you want to write it into the picture, that might be helpful. Now I'm going to check the same thing for these. Okay. Subtract the x's, square that. Subtract the y's, square that. 2 minus 3 is -1. -1 squared is 1. -1 plus 2 is 1. 1 squared is 1. That is another square root of 2. Okay. Now all I have to do is check the third side right here and right here. So that's S and R. So I'm going to do that right here. So subtract the x's, subtract the y's. Negative 2 plus 5 is 3. 3 squared is 9. Negative 2 plus 1 is negative 1. Negative 1 squared is positive 1. That is square root of 10. So that was SR, which is right here. Now I'm going to do the same thing for the last side, which is ND, these two. So n to d would be 3 minus 2, subtract the x's, and then negative 2 plus 5, subtract the y's. 3 minus 2 is 1, 1 squared is 1, negative 2 plus 5 is 3, 3 squared is 9, and when you add those you get 10. So this is also square root of 10. So once you verify that all three sides have the same length, they're all corresponding, all the same length, then you would say yes, they are congruent by side, side, side. Okay? Now the slope method that you guys could use may be a little bit confusing in this situation because it's a little bit weird because we have a vertical and a horizontal. So if you were to find the slope of this one, that's undefined, and the slope of this one is 0. Now I know that seems like they're not the same, but it's just because, excuse me, one has been reflected. Sorry, it's been rotated a little bit, so instead of being horizontal, it's vertical. But we can consider that undefined and the slope of 0 to be the same in this situation because they are flat that way. What we really want to focus on is on the other two. So this short side has a slope of 1 over 1, right? And then this one has a slope of 1 over 1. And this one has a slope of negative 1 over 1. So they both have the ones there to create that slope. And then this slope has the down, let's see, 1, 2, 3, down 3 over 1. This one has down 1 over 3. So they both have those two numbers, the 1 and the 3. They're in different spots, right? One had the 1 on the top and the 3 on the bottom, and then it was reversed over here. But as long as they have the same numbers, whether it's 1 over 3 or 3 over 1, excuse me, then you can kind of analyze the slopes and see that they work that way too. They've just been rotated to change the negative and the arrangement of the numbers. So again, that's why I don't like suggesting the slopes method, because it can be confusing with how the numbers swap within the fractions and the signs change when you turn the triangles. So if that doesn't make sense to you on why they would be the same, even if it's they become reciprocals, then please don't use the slopes method. Just stick with the distance formula and verify that they're all the same length and go from there. Now, is that it? Yeah, we're almost done. So the rest of these, we had a couple of review questions on the test. So this is to set your foundation for those. So I do ask a midpoint question. I ask a question about supplement and complement. And then I ask about our logic unit, where you're turning something into symbols using A and B. And then I have parallel lines review here. So you guys should remember a midpoint is when you add the x's, divide by 2, add the y's, divide by 2. So for that one, you should get 2, 1. If you use the formula, look it up if you don't remember. For this one, it says, if the supplement of S is 100, what is the complement? We actually had a question like this on the graded assignment we're working on right now. I believe it was question number 1. So this is like 2 questions. They're saying if the supplement of S is 100, so this is the hypothesis, what is the complement of angle S? Well, you can't find the complement of angle S unless you know what angle S is. So that's what this is for. This first half is to help you find what the measure of angle S is so that you can actually find the complement of it. So if we know that the supplement of angle S is 100, that means that angle S plus 100 equals 180. And that's what a supplement is. When you add it on to this, they should equal 180 together. So that means that angle S is 80 itself. And then when they ask you for the complement of that, that means that angle S plus what equals 90. Well, I know angle S is 80. So 80 plus what equals 90? Well, 10. Okay, so it's a 2-part question. That's how you approach it. Hopefully, if you didn't know how to do that on the graded assignment, now you know. This one has A and B stand for different parts of the sentence. So if we're starting with if the sky is cloudy, it will not be sunny. So this is an if-then statement, so we're going to need an arrow. The sky is cloudy is the start, so I'm going to start with A. And then it says will not be sunny. That's the opposite of B, so squiggle B. And this one I'm working with parallel lines. So the parallel lines are here and here. Okay, I have 2 different transversals. Now this is interesting because this transversal right here only has these two angles and it doesn't involve an angle up here. So I don't want this transversal. It's not helpful in any way. So I'm going to pretend that transversal is not here, but only after I move the 88 up here. All right, so you needed this transversal for a second to have that crisscross to get the vertical angles up here. But once you move the 88 so it's adjacent to the x, because when they're separated, it's really not helpful. You want the 88 to be adjacent to or right next to x. So use the vertical angles to shift that. And then I'm going to ignore this transversal because it doesn't have two angles, one up here and one down here. That's not how it works. This transversal, however, this one right here, has the 49 up here on this side and the 88 and the x down here. So this is the transversal I want to focus on. Now if I redraw the picture, which I'm going to do right here, I draw the transversal. I have the 49 right here. Now because I took this transversal away, you guys have to remember we talked about this. When you take a transversal away that used to be cutting an angle into two parts, to represent this full angle, you have to take these two and put them back together. So this angle would be x plus 88. Okay, so remember when you're trying to ditch a transversal, but it's cutting an angle into two parts, you have to add them back together to get the full angle. Okay. Now currently these two angles, as they are, don't have a relationship. So I'm going to have to move that 49 right here using vertical angles. Some of you guys are making a weird mistake in moving it here. Right, you can't do that. Right, they're a linear pair, which doesn't mean that they're equal. But if you want to keep it equal and shift it to a different angle, you have to use the vertical. So I'm going to move the 49 here, and then these two angles are consecutive interior, which means that they equal 180. So if you do x plus 88, let's see this, plus 49, that should equal 180. And then you can solve that equation, and hopefully once you do the algebra, you should get x equals 43. Okay? Then the last one here just says, in the figure below, R and S are parallel. Okay? The measure of angle 3, which is right here, is 3x minus 105. And the measure of angle 6, which is right here, is 2x plus 10. I don't have a whole lot of room, so I'm not going to write it in here, but if you want to, you can. I noticed that angle 3 and angle 6, again, are consecutive interior, and consecutive interior angles are supplementary. So I can take both of those and set them equal to 180 after I add them. So 2x plus 10 plus 3x minus 105 equals 180. It's the relationship between those two angles. So I would combine like terms and I would solve x equals 55.